Okay. Now we will talk about uniqueness and continuous dependence. Okay. Recall that for a well-posed problem, we should have a unique solution. So there is existence, uniqueness, and continuous dependence on the initial and boundary data. So this is the uniqueness and continuous dependence part. We will consider the existence later. When we solve the equation, it will be the existence, right? We will find the solution. Daha iyi existence mi olur? Değil mi? Evet. Alın size. So, uniqueness result. Pardon. Let u1 xt and u2 xt be two solutions of the problem. Which problem? It is the following problem. It is a partial differential equation, and it is, of course, the heat equation on an interval, I mean, rectangle like this. Well, not rectangle, it's an infinite strip. Here we don't put, equivalence, equality, because we are taking derivatives, so we don't require the existence of the derivatives at the end of the interval. We have boundary conditions. What are they? 0t equals gt, ult, ht, and initial condition ux0 equals f of x. So here is the problem. I have an infinite strip like this. Okay, so this is the t direction. This is the x direction. This is x equals 0, x equals L. On the inside this region, this equation is satisfied. On this infinite ray, the temperature is GT, right? At a point like this, 0T, x is 0, so this is a point 0T. This is the point LT, and here the temperature is H of T. Evet. Yani L de büyük sıfır tabii de, ama haklısın. And here, boundary condition, this is a point where x and t is 0, and here the temperature is Fx. Yani bu ne demek? So we have, you may think of as follows. We have a, let's say, metal object of length L. UXT is the temperature at place, position X and time T. Yani şurada bir X noktasında ve T saniye sonra. So T seconds later, at this point, the temperature is this much. And what we know is that the temperature at this end is given by this function. So it's a function of time, and it changes in time. Here, the temperature is again a function of time, and it's given by HT. So I can control the temperatures of the two ends of this bar, and initial temperature distribution is given by this function. So when T equals 0, the temperature at this point is f of x when T equals 0. Yani başlangıç anında şu noktadaki sıcaklık T'ymiş. Ondan sonra tabii ki zaman içinde değişecek, değil mi? Buraları ısıtabilirim, soğutabilirim. Right? So initially temperature is f of x, but then it will change, right? So this theorem tells us that any two solutions of this equation are equal. Therefore, this equation, this problem, not equation, we should say problem, it consists of an equation and then some boundary conditions and initial condition. Right? These are the boundary conditions, and then we have initial condition. And theorem tells us that it is a unique solution. Well, why is that? Let's see. Proof. Set WXT to be U1XT minus U2XT, the difference of the two solutions. Then, of course, then WT would be just alpha squared WXX, since I mean WT is just U1T minus U2T, and WXX is just U1XX minus U2XX. And since U1 and U2 both satisfy this equation, and this equation is linear, their difference also satisfies. Okay? Oh, okay. Well, uniqueness result, so what should be the statement? Then U1 is equal to U2. Okay? Tamam mı? Ne? Tabii ki bütün region'da bunlar birbirine eşit. Şimdi also note that W 0T is what? U1 0T minus U2 0T. Well, this was GT minus GT. So this is 0. And similarly, WLT is just U1 LT minus U2 LT. So this is just HT minus HT, and it's also 0. Moreover, W x0, the initial temperature distribution, is what? U1 x0 minus U2 x0. Well, both of them are f of x, so this is equal to 0. So what we see is then, hence, Wxt is a solution of the problem. Which problem? Denklem aynı. The equation is the same. Wt is alpha squared Wxx. But both boundary conditions and initial condition are homogeneous. In other words, W0T is equal to 0. WLT is 0 for all t. And no, for all t. And for t equals 0, Wx0 is just, that's also 0. So initial temperature is 0. The both ends are kept at temperature 0. And then we would like to see how the temperature will change. Ne olur sizce? Sıcaklık. Dışarıdan da bir şey gelmiyor. O zaman değişmez. Değil mi? So there is no external heat source, right? F is 0 because when you write it like this is 0. Initial temperature distribution is 0. And at the ends, the temperature is kept at 0 for all times. So the temperature of this metal bar should be 0 at all times. In other words, this function should be just 0. Therefore, the two should be equal to each other. But of course, that's not a proof, right? Fizikçi ispatı olur bu. Let's see why this is true. Ama yani sonuçta iş oraya geliyor tabii ki. Bakalım. Now, by the maximum principle, for homogeneous equation, for f xt equals 0 case, and external heat function is 0. Sağ ol. Su içmekten değil ya, çayım var. Sağ ol. Teşekkür ederim. Okay. By the maximum principle, we must have the maximum of w xt should occur at a point, which point x equals 0, x equals L, and t equals 0. Değil mi? Ama buralarda sıcaklık hep zaten 0. Right? Temperature here, here, and here are all 0. So whatever the maximum is, it should be 0. Hence, the maximum of wxt on this infinite, on the whole region, is 0. Burada şunu da görüyorsunuz. We can interchange the roles of U1 and U2. It will multiply W with minus 1. But, you know, the roles of U1 and U2 are the same. So this means that the same thing would say that minus W has maximum equals 0. But the maximum of minus W is the minimum of W. Therefore, the minimum of W, whatever it is, it's also 0. So this function has maximum and minimum, which are both equal to 0. Therefore, this function should be constantly equal to 0, right? Ama orada f'i negatif alın diyordu. Ha, sıfır aldım işte. Anladım. Tamam. Tamam. Anladım. Anladım. Okay. Neyse, replacing U1 and U2 will replace W by minus W so that W should take okay, so that the minimum of W should be also 0. Hence, WXT should be 0 for all x between 0 and L and t positive. So this implies that U1 xt equals U2 xt. Okay. Bunu da anladın. All right. Teorem 5. Neyse, teorem de yazayım. Numaralandırmadık. Continuous dependence on the initial conditions and boundary conditions. All right. Let U1 xt and U2 xt be the solutions solutions. Artık the solution diyebiliriz, değil mi? You know that there is a unique solution. I no. We don't know whether there is a unique solution. If there is a solution, then it is unique. Okay, so we can say the solutions of the problems below, respectively. Birisi şu olsun. Ut equals alpha squared uxx. U0t equals g1t. ULT is h1t. Ux0 equals f1t. And the second problem is this. Equation is the same, but the initial conditions are possibly different. U0t is this gt, ULT is H2T, and the initial temperature distribution is F2T for some functions. If F1x minus F2x is less than epsilon for all x on this interval, and G1t minus G2t is less than epsilon, and H1t minus H2t is less than epsilon for all t. Şurada şöyle bir aralık için. Yani zaman sonsuza kadar giderse onun için bir şey söylemiyoruz da sonlu zamanda en azından. Then we have, şunu iddia ediyoruz. Bu iki çözüm de epsilon kadar birbirinden fark ederler. Xt minus u2 xt is less than epsilon for all x is in 0 L and t is in 0 t. Bu da, so this is a continuous dependence, right? If the initial conditions are epsilon apart from each other, then the solutions are at most epsilon apart from each other. So the solutions depends continuously on the initial conditions and boundary conditions. Öbür türlü şöyle olurdu, değil mi? İşte ısıtıcıyı hafiften açıyorsunuz. Isıtıcı bir anda 1 milyon dereceye çıkıyor. Ee, O hoş olmaz. Bakayım. Evet. T. Evet, şöyle bakarsanız tamam. Yok bu X ya, özür dilerim. Bu tabii X bu. Yeah, this is X. I am sorry. Yani burada X, burada T koyuyorsanız o zaman, değil mi? Let's see the proof of this. Okay. So let Vxt to be Vx U1 xt minus U2 xt. Then we can see that this is just U1 t minus U2t, but U1 t is just alpha squared U1 xx, and this is alpha squared U2 xx, and this is just, of course, alpha squared U1 xx minus U2 xx, but that is just this. Therefore, Vt satisfies the heat equation, and Vx0 is just what? This is U1 x0 minus U2 x0, but both of them, okay, this is, sorry, this was U1 G1. No, this is F1. F1 and F2, and that difference by assumption is less than epsilon. V0 t is U1 0t minus U2 0t. That is G1 t minus G2 t, but that is less than epsilon. And finally, V LT is U1 LT minus U2 LT, H1T minus H2T, and that's also less than epsilon by the assumption. So what we see is that hence thus the maximum value of Vxt which is attained on nerede bu? Ya x'in 0 olduğu yerde, or x'in L olduğu yerde, or t'nin 0 olduğu yerde, değil mi? Is not greater than epsilon. Değil mi? Çünkü on this line segment it has a maximum. I mean, the maximum is on this pieces, and on that pieces, the absolute value of this is less than epsilon. Therefore, whatever the maximum, it should be less than epsilon. Similarly, the minimum is greater than minus epsilon. Therefore, it follows that this gadget is less than epsilon for all x between 0 and L and T. And that's the end of the proof. Tamam mı? So once we show that there exist also solutions, we will we can say that heat equation or heat problem is a well-posed problem. Okay. Evet. Yani bir tane daha sonuç var ama ona gerek yok şimdilik. Okay. All right. So I think we can stop here. So next time we will see so-called method of separation of variables that will provide solutions to the problems involving heat equation. So we will have heat equation with some boundary conditions and initial condition, and we will solve that equation. We will find solutions, and we know that solution is unique once it exists. Okay, we may stop here.